Hello friends, today we'll try to complete the keywords of chapter 13. The topic is light. In the old book the chapter number is 16. In my last video I had covered about 9 words. So we'll take up the remaining words and try to understand them. So first word is lateral inversion. Lateral inversion means basically when you look in a plane mirror, you find that the right side of the object appears on the left side and the left side of the object appears on the right side. So let us say we are standing before a mirror. You are standing here, and if you raise your right hand, you will feel as if the image in the mirror is raising the left hand. And if you raise the left hand, you will feel that the image in the mirror is raising the right hand. तो जो right side है वो left दिखाई देती है, left है वो right दिखाई देती है. This is called lateral inversion. Image is erect. ठीक है, यहाँ पे ऐसी image है और erect दिखाई देगी. This is the top, this is bottom, this is top, this is bottom. The only thing is anything which is on the right side will appear here, anything which is on the left will appear here. Okay? So lateral inversion means that when you see an image of an object in a plane mirror, you feel that the right side is on the left side and the left side is on the right side. Whatever is on the left side will appear on the right side and whatever is on the right side will appear on the left side. That is called lateral inversion. ठीक है? अगर आप जैसे P लिखोगे मिरर के सामने तो आपको ऐसा दिखाई देगा. If you write K, K will appear like this. Okay? So this is called lateral inversion. So what is the next word that we have to learn? We have to learn the laws of reflection. There are two laws. First law is that angle of incidence is always equal to angle of reflection. When light reflects from a plane mirror, the angle of incidence is always equal to angle of reflection. This is plane mirror. This is a beam of light. It is coming here. This is normal. This is incident ray, reflected ray. This is angle of incidence. This is angle of reflection, IR. I is always equal to R. If I is 30 degree, R will be 30 degree. If I is 90 degree, this will also be 90 degree. If it is 100 degree, this also will be 100 degree. Okay? Supposing this is normal. The ray of light falls on the normal. So it will come back on the same line. That is the first law. What is the second law? Second law is that the incident ray, the reflected ray, and the normal drawn at the point of incidence, they are in the same plane. Okay? For example, this is one plane, this is incident light, this is reflected light, and this is the normal. They are in the same plane. ऐसा नहीं होगा कि ये ऐसे चला जाए या नीचे आ जाए. All three will be in the same plane. The level between them will be same. So that is called the second law of reflection. The incident ray and the reflected ray and the normal at the point of incidence. Normal जहाँ बनाया हमने, कहीं और नहीं बनाना. All three are in the same plane. So now we'll come to the next word. Pupil. This is a small black opening in the iris. ये हमारी आंख है. This is iris. ये बीच में सेंटर में होता है. And the light enters through the pupil. Whatever images we are seeing, it is because of the light entering into our eye through the pupil. And the size of the pupil is controlled by the iris. If we are in bright light, the size will become smaller. The iris will reduce the size of the pupil. And if we are in dark light, dim light, if we are in dim light, the size of the pupil become large, so that more light can enter the eye. And we can see things in a better way, more clearly. So pupil is the dark spot or dark opening in the eye, center of the iris, and the light rays enter our eye through pupil. So what is the next word? Reflected rays. Reflected rays are rays, these are rays which bounce back from a surface. When some light is falling on that object. For example, some light is falling on this whiteboard and some light is being reflected back. It is bouncing back and entering into our eyes. And that is why we see the whiteboard. So, and when we draw the diagram, it is like this. This is the incident ray and this ray is bouncing back. जैसे कैरम में आप उसको मारते हैं स्ट्राइकर को, वो टकरा के वापस आता है. It bounces back. तो वैसे ही ये लाइट जो है बाउंस बैक कर रही है. So that is called the reflected rays. Reflection. Reflection means bouncing back of the light. When light strikes a surface, it bounces back. So this process is called reflection. And reflection also means the image that is formed in a mirror or appears to have been formed by a mirror. So it refers to both the image and it refers to the process of bouncing back of the light. Light being thrown back. That's called reflection. Regular reflection तो मैंने आपको पिछले वीडियो में समझा दिया था. Now we come to retina. Retina is the inner lining of the back side of the eye. This is the front side, cornea, through which and pupil through which light enters our eyes, and this is the back side of the eye. So this is a lining here, and it is made up of many cells, but the most important cells are cone cells and rod cells. These cone cells and rod cells generate electrical impulses when light falls on them. And those impulses through optic nerve go to our brain, and then an image is formed in our brain and we see that thing. We see because of the electrical impulses generated by the cells in the retina. These cells are cone cells and the rod cells. Those electrical impulses go to our brain through optic nerve and we see an image. Rod cells. Last is rod cells. So rod cells, as I explained, these are cells in the retina and they are sensitive to dim light. Cone cells are sensitive to bright light and rod cells are sensitive to dim light, and their number is greater than the number of cone cells. Rod cells का जो number है cone cells से अधिक होता है. Okay, so that covers all the keywords of the chapter 13, and if you have carefully watched my video, you would have understood most of the points that have been covered in the topic. Okay, so if you like my video, please share it with your friends and subscribe my channel. Thank you.